Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is the first problem. Second problem, you can see I not done third problem, fourth problem because we are doing all the problems model wise. Okay, not number wise. Model wise I am doing all the problems so that you will feel easy to learn these things. Okay, next question number 5 completed. Question number 6 completed. Question number 7, 8, 9 not done because they are of modulus function type problems. So in next class I'll do all those things. Now in this class what problems we are going to do? This 10th problem. You see 10th problem, find all points of discontinuity is there here. In 10th problem you can see find all points of discontinuity. And 11th problem. In 11th problem also find all points of discontinuity. And 12th problem. These are the problems we are going to do in this class. Okay. Now, what is this 10th question? Many students feel difficult to understand these problems. Actually, we do this problem in 3 cases. Right, you see here what they are asking. Find all points of discontinuity. Find all points of discontinuity of the function f. This is the given function. First point, what is the domain of this function? For example, x equal to 100 is given. X value is 100. Then here two functions are there. One is x plus 1, another one is x square plus 1. In these two, which function to choose? When x is 100, here what you observe here two things are there. X value greater than or equal to 1, then we will choose this function. When x value less than 1, then we will choose this function. Okay. Here when x equal to 100, suppose x equal to 100. 100 is less than 1 or greater than 1? 100 is greater than 1. So we will choose the first function. Suppose x value equal to 0. X value 0. 0 is greater than 1 or less than 1. Like that we need to think. 0 is less than 1. So we will choose this function. X square plus 1 second function. Like that x value is 1 crore. X value is 1 crore. Then x value is 1 crore. Then which function to choose? 1 crore is greater than 1. So we will choose the first function. X value is minus 1 crore. Minus 1 crore is less than 1. So we will choose the second function. Okay. So what is the domain of this function? Domain of this function is all real numbers. Domain of this function is all real numbers. But this function varies at x equal to 1. When x is greater than 1, first function. When x is less than 1, the second function. So I do this problem in 3 cases. How? What are those 3 cases? First, I'll suppose this is the 1. I'll take this part. What they are asking in the question? Find all points of discontinuity of the function. That means, what is the domain of this function? I came to know that domain of this function is all real numbers. To checking the continuity at all the points. So many points are there, infinitely many points are there. Where to check? We cannot check at each and every point because time is not sufficient. So what I'll do this problem in 3 cases. First case is in this zone. You observe here, this is the area. In all this part, x value, a value is less than 1. I'll take this as case 1. And case 2, at a equal to 1. At a equal to 1, that I'll take it as case 2. Next, when a is greater than 1, I'll take this as case 3. I'm going to do this problem in 3 cases. Okay. In all the 3 cases, I'll check where it is continuous, where it is discontinuous. Okay. First, we'll start the solution. Solution for this problem. Solution. Okay. Case 1. What is case 1? A given function is clear for us. What is case 1? I'll take like this. X equal to, I'm checking the continuity at x equal to a value is less than 1. Here, what is a value? I am checking the continuity in this zone. A value may be any number in this zone. Please try to understand. Can I take a value 0? Yes. 0 is there here. Na? Yes, you can take. Can I take a value is minus 3? Yes, you can take. Here, what is a value? A value you can take any number which is less than 1. That means I am checking continuity in this zone, in complete this zone. I am checking continuity at x equal to minus 100. I am checking. So this is the case 1. I am checking continuity in this zone. That is case 1. Case 2 is what? I'll check the continuity at 1. Case 3 is what? I'll check the continuity when a value is greater than 1. Okay. Right. Now, what I'll do? When we say function is continuous at x equal to a, we know this formula. Limit x approaches to a, f of x equal to f of a. limit x approaches to a, f of x equal to f of a, then we say that this function is continuous at x equal to a. Correct? Okay. Here, what is a value? A value is any number less than 1. First, what I'll do, I'll calculate this one. Limit x tends to a, f of x. Next, I'll calculate f of a. I'll check both are equal or not. If both are equal, then I say that this function is continuous at x equal to a. Okay. Right. So, what I'll do here, limit x approaches to a, f of x. I'm trying to calculate this one. Okay. Here, limit x approaches to a, what function to choose? What function to choose? What is a value here? A value is less than 1. A value is less than 1. Here a value is less than 1. When a value is less than 1, which function to choose? This x square plus 1. Okay. So what is the function here? Function is x square plus 1. Okay. Function is x square plus 1. Okay. That equal to. Now I need to calculate limit of this function. How to calculate limit? In this function, wherever x is there you write a. We do this problem by direct method. What is direct method? In this function, wherever x is there you write a. Write a, what you will get? That equal to a square plus 1. Okay, a square plus 1. Now, what to calculate? I calculated this one, I got a square plus 1. Now, I'll calculate this f of a. Okay, f of a. How to calculate this f of a? F of a. To calculate f of a, you need to know what is the function. What is the function to choose here? I'll write here f of x. Here, what is a value? Look here, what is a value? A value is less than 1. When less than 1, we need to choose this function. So here, when a value is less than 1, f of x is x square plus 1. F of x is x square plus 1. When f of x is x square plus 1, what is f of a? F of a is a square plus 1. Right? So here, what is f of a? F of a is a square plus 1. What happened? I calculated limit x tends to a, f of x. I got a square plus 1. F of a is a square plus 1. See here, I calculated this, I got a square plus 1. I calculated this, I got a square plus 1. So what I can say? I can say this, therefore, limit x approaches to a, f of x equal to f of a. Therefore, what I can say? Therefore, f of x is continuous at x equal to a whenever a value is less than 1. So, I checked the continuity of this function in this zone. This is case 1. This part I will mark here where I checked the continuity. This part I checked the continuity. This zone I checked the continuity. This is first case. So what you came to know? You take a value in this zone. Any a value in this zone. Then this function is continuous function. That is what I identified. Now what is case 2? I will check continuity at this point. At 1. Okay. We will start this case 2. I'll do one thing, I'll bring the function to avoid the confusion. Okay, this is the function. This is the function. I am checking the continuity case 2 at x equal to a. A value is what? I need to bring this one also. Okay, please observe this one at x equal to a. Where I am checking the continuity? At 1. A value is 1. That means I am checking the continuity at x equal to 1. When we say function is continuous at x equal to 1, when we say function is continuous at x equal to 1, you observe here, limit x tends to 1, f of x equal to f of 1. Limit x tends to 1, f of x equal to f of 1, then we say that function is continuous at x equal to 1. So for that, what I need to do? First, I will calculate this one. Next, I will calculate this one. If both values are same, then I say that this function is continuous at x equal to 1. Okay. Here, difficult part is calculating this one. Limit x tends to 1, f of x. Why it is difficult one? Let me explain. Limit x approaches to 1, f of x. I need to calculate this. Okay. Limit x approaches to 1. Now the point is what function to choose. What function I need to write here? Here what they given? X approaches to 1 given. X approaches to 1 means all x values are slightly less than 1 or slightly greater than 1 but not 1. Is this clear? X approaches to 1 means what? All x values are slightly less than 1 or slightly greater than 1 but not 1. You look at this one, x approaches to 1 means x values are in the neighborhood of 1. Suppose this is 1, x approaches to 1 means all x values are in the neighborhood of 1. Already we discussed these things, I don't want to spend much time on this. What point you need to know here, x approaches to 1 means x values are slightly less than 1 or slightly greater than 1 but not 1. So now you tell me what function to write here. What function to write here? X plus 1 or x square plus 1? Which function to write? You please answer. X approaches to 1 means x less than 1 possible? Yes. When x is less than 1, we need to choose this function. X approaches to 1 means x value is greater than 1 possible? Yes, possible. At that time, we need to choose this function. So x approaches to 1 means we need to choose this function or this function. Both are possible. So there is a confusion to write what function to write. So to avoid this confusion, best thing is calculate left hand limit, right hand limit. Okay. So what I'll do here, right? What I'll do, I'll calculate left hand limit. Calculating left hand limit. Limit x approaches to 1 from left, f of x. Now no confusion will be there. Limit x approaches to 1 from left. X approaches to 1 from left. What it means? X approaches to 1 from left means all x values are less than 1. Very nearer to 1 but not 1. X approaches to 1 from left means all x values are less than 1. When x values are less than 1, which function to choose? It is clear. When x values are less than 1, we need to choose the function x square plus 1. So I'll write that function x square plus 1. Okay. Now I need to calculate this one. How to calculate limit? For any limit problem, first we try by direct method. Okay. What is direct method? In this function, wherever x is there, there you write 1. So what you will get? 1 plus 1. That is 2. Okay. Right. Now, what happened here? I just calculated this one. I got its answer as 2. I just calculated left hand limit. What to calculate now? I need to calculate right hand limit also. Okay. Okay. Right hand limit. You observe here, limit extends to 1 plus f of x. Here, I need to calculate right hand limit. Limit x approaches to 1 from right. X approaches to 1 from right means all x values are greater than 1. X approaches to 1 from right means all x values are greater than 1. When x values are greater than 1, which function to choose? First function, x value greater than 1, we need to choose x plus 1. Okay. In place of f of x, you write x plus 1. Now, I want to calculate limit of this function. How we will calculate limit? For any problem, first we try by direct method. So, in this function, wherever x is there, there you write 1. So, what you will get? 1 plus 1. 1 plus 1 is 2. What happened here? Left hand limit, right hand limit, both are same or not? Left hand limit value is 2. Right hand limit value is also 2. So, left hand limit equal to right hand limit. Then we say limit exists or doesn't exist. When left hand limit is same as right hand limit, then we say that limit of the function exists. So, what I'll write here? Therefore, limit x approaches to 1 f of x. I got this value. What is this value? I got this value as right. So, I just calculated this one. I got its answer as 2. Okay. Now, what to do? I need to calculate f of 1. I'll calculate f of 1. To calculate f of 1, we need to know what is the function to choose. Okay. F of 1 you want. Okay. I'll write here f of x. F of x. Here, in place of f of x, 1 is there. Na? When x equal to 1, which function to choose? Look here, this one, equality symbol is there here. You observe this one, in this equality symbol is there. When x equal to 1, here x, in place of x, here 1 is there. You observe this one, in place of x, here 1 is there. Right? So, we need to choose this function. F of x is what here? F of x is x plus 1. What is f of 1? In this, in place of x, you write 1. 1 plus 1 is 2. So, finally, what I am trying to say, f of 1 is what? F of 1 is 1 plus 1, that is 2. So, I calculated this value, I got 2. I calculated this value, I got 2. As these two are same, what is the conclusion? I will write here. Therefore, limit x approaches to 1, f of x equal to f of 1. When I got this statement, what I can conclude? I can conclude that this function is continuous at x equal to 1. So, I'll write the same thing. Therefore, f of x is continuous. F of x is continuous at x equal to 1. So, what happened? at this this is case 1. I came to know that it is continuous in this zone. Now in case 2, I checked the continuity at this point. What I got it is continuous at x equal. I got it is continuous at x equal to 1. Now I need to check case 3. I need to check continuity in this zone. I'll take it as case 3. Okay, we need this one, so can you see it? Right. Okay, case and function also needed. Now we'll bring that function also. Okay, good. This is the function. Now we are checking the continuity at case 3. This is case 3. We are checking the continuity at x equal to a. What is a value here? I am checking continuity in this zone. A value is greater than 1. I am checking the continuity in this zone. Okay, in this zone means what is the a value? Can I take a value 100? Yes, 100 is greater than 1. You can take. Can I take a value is minus 1? No, you cannot take a value minus 1 because minus 1 is not greater than 1. Can I take a value 200? Yes. Can I take a value 2? Yes, you can take. So I am checking continuity in this zone. I hope you are understanding. Okay. So when I say function is continuous at x equal to a, general thing, limit extends to a, f of x equal to f of a. Then we say that this function is continuous at x equal to a. So what I'll do, first I'll calculate this limit extends to a f of x. Okay, limit x approaches to a f of x. I'll calculate this first, that equal to limit x approaches to a. Okay, here what is f of x? What is f of x? X approaches to a. X approaches to a. A value is what? A value is greater than 1. When a value is greater than 1, which function to choose? First function. So what is f of x here? F of x is x plus 1. Now I want to calculate limit of this function. How to calculate? Direct method. In this function, wherever x is there you write a. So what you will get? You will get this equal to a plus 1. Okay, what happened? I calculated this one. I got a plus 1. Now I'll calculate f of a. I'll need to calculate f of a. Okay, to calculate f of a, do not confuse what is function you decide. Here what is a value? What is a value? A value is greater than 1. A value greater than 1 means we need to choose the first function. So f of x is what? F of x is x plus 1. What is f of a? What is f of a? F of a is a plus 1. Right? F of a is what? F of a is a plus 1. What happened? I calculated this one. I got a plus 1. I calculated this one. I got a plus 1. That means these two values are equal. So I'll conclude that. Therefore, limit x approaches to a, f of x equal to f of a. What is the conclusion? When I got something like this, what I can say? I can say that function is continuous at x equal to a. Okay, I'll write the same thing. Therefore, f of x is continuous. F of x is continuous at x equal to a whenever a value is greater than 1. So what happened? I checked the continuity in this zone also. Okay, in case 1, what I got? In case 1, I got that it is continuous function. Case 2, in this zone, what I got? It is continuous at x equal to 1. Case 3, in this zone, I got that it is continuous function. So I came to know that this function is continuous in its domain. So what I'll conclude? Therefore, from case 1, case 2 and case 3, what is the conclusion? F of x is continuous function. F of x is continuous function. Continuous function means what? It is continuous everywhere. But in the question what they are asking? Find all points of discontinuity. But what I got? I got that this is continuous function. I got that this function is continuous function. That means what? That implies there is no point of discontinuity. There is no point of discontinuity. I hope you understand. There is no point of discontinuity. Good. Now 11th problem, very similar. Okay. Find all points of discontinuity of f where function is defined like this. Now, to check all points of discontinuity of this function, first thing I need to know domain of this function. Can anyone say what is domain of this function? Is this function is defined for all real numbers? Suppose x equal to 100 is there. Which function to choose? 100 is greater than 2. So we need to choose this function. Suppose x equal to minus 1 is there. Then which function to choose? Minus 1 is less than 2. Minus 1 is less than 2. So we need to choose this function, x cube minus 3. Suppose when x equal to minus 4 is less than 2 na? So we need to choose this first function. What I am trying to say, what is the domain of this function? Domain of this function is what? Domain of this function is all real numbers, right? So I need to check the continuity of the function on its entire real numbers. But you observe here, this function varies at x equal to 2. When x is less than 2, we need to choose this function. When x is greater than 2, we need to choose this function. So I do this problem like this. Case 1, case 2, case 3. What is case 1? I'll check the continuity in this zone first. That comes under case 1. Okay. And I'll check the continuity at this point. That is case 2. And I'll check the continuity at this point. Okay. That is case 3. So we are going to do this problem in 3 cases. Let's start. Solution. Case 1. Case 1. What is case 1? At x equal to a value in this zone. In this zone I am trying, a value is less than 2. A value is less than 2. When we say function is continuous at x equal to a, same story. This is the hero of the story. This is the one and only one formula we have, right? Limit extends to a, f of x equal to f of a. When we say f of x is continuous at x equal to a, answer, limit extends to a, f of x equal to f of a, then we say that function is continuous at x equal to a. So, limit extends to a, f of x equal to f of a, then we say that this function is continuous at x equal to a. What I'll do first, I'll calculate this, next I'll calculate this, later I'll check both are equal or not. Okay. First I need to calculate limit x approaches to a, f of x. Limit x approaches to a, f of x. Okay. I need to calculate this. So for what function to choose? Limit x approaches to a, what function to choose? Here, what is a value? A value is less than 2. When a value is less than 2, which function to choose? This function, x cube minus 3. Okay, that is x cube minus 3. Now what to do? I need to calculate limit of this. How to calculate limit of this? For any problem, first we try by direct method, right? In this function, wherever x is there, I'll write a. Okay, what you will get? That equal to a cube minus 3. So what happened? I calculated this part. I got a cube minus 3. Now what to calculate? I need to calculate f of a. Okay. I need to calculate f of a. Okay. F of a. What is f of a? To calculate f of a, we need to know what is f of x. F of x. Here, what is a value? A value is less than 2. When a value is less than 2, which function to choose? This function. What is this function? X cube minus 3. This function is x cube minus 3. Okay. Now what I need? I need f of a. What is f of a? F of a is a cube minus 3. Right? So f of a is a cube minus 3. Okay. Right. So here what happened? I calculated this one. I got a cube minus 3. I calculated f of a. I got a cube minus 3. So what I can conclude? What happened here? I calculated this one. I got a cube minus 3. I calculated f of a. I got a cube minus 3. So what is the conclusion? This equal to this, right? I'll bring the same thing. So what happened here? I got that therefore limit extends to a, f of x equal to f of a. So from this what I can say? I can say that f of x is continuous. F of x is continuous at x equal to a. What about a value here? A value is less than 2. That means what happened? I checked continuity in this zone. This is case 1. What I came to know? I got that this is continuous at x equal to a whenever a value is less than 2. So I checked the continuity in this zone. So there is no point of discontinuity in this zone. So what is the second case? Second case, I'll check the continuity at x equal to a and a equal to 2. I'll check the continuity at a equal to 2. Okay. What I'll do? I'll bring this function. Case 2. Case 2. What is case 2? At x equal to a, here a value is very clear. I am checking the continuity at 2. This case is little difficult. This case is little difficult. What I am doing now? I am checking continuity at x equal to 2. Only one point. I am checking continuity at x equal to 2. When we say a function is continuous at x equal to 2, this is the point. Limit x approaches to 2, f of x equal to f of 2. Limit x tends to 2, f of x equal to f of 2. Then I say that this function is continuous at x equal to 2. Correct? Okay. So what I will do here, limit x approaches to 2, f of x. I need to calculate this. Limit x tends to 2, f of x. Here the problem. What is the problem? You will get to calculate this. Limit x approaches to 2, f of x. I want to calculate this. Okay. Limit x approaches to 2. What function to choose? What function to choose? You tell what function to choose. Here I need to choose this function or this function. X approaches to 2 means what? What we learned in first class? X approaches to 2 means all x values are slightly less than 2 or slightly greater than 2 but not 2. Correct? All x values are slightly less than 2 or slightly greater than 2 but not 2. Okay. So here x value less than 2 possible. When x value less than 2, we will choose this function. When x value greater than 2, then we will choose this function. So both functions are possible in this case. But what function to write? So to avoid this confusion, best thing is calculate left hand limit, right hand limit. While calculating left hand limit, right hand limit, you don't get any confusion. You see, for example, left hand limit. I will calculate left hand limit at x equal to 2. That means limit x tends to 2 minus f of x we need to calculate. You observe here, x tends to 2 from left. X tends to 2 from left means all x values are less than 2. X approaches to 2 from left means all x values are less than 2, very nearer to 2. Less than 2. Less than 2 means which function to choose? This x cube minus 3. There is no confusion to choose in this. So what I will do here, limit x approaches to 2 from left. Which function to choose? Here x approaches to 2 from left means all x values are less than 2. So I will choose this function. So the function is x cube minus 3. Okay. Now I need to calculate this one. Limit of this. How to calculate limit of this? We will try by direct method. What is direct method? In this function, wherever x is there, there you write 2. So what you will get? You will get that 2 cube minus 3. That is 8 minus 3. 8 minus 3 is what? 5. So what happened? I calculated this. Limit x tends to 2 f of x. I got? No, not yet calculated. What I did here? I calculated left hand limit. Now I need to calculate right hand limit also. If right hand limit also 5, then we will conclude. Right? So what I will do here? I need to calculate right hand limit. To calculate this one, I decided to calculate left hand limit as well as right hand limit. So I am calculating right hand limit. What is right hand limit? Limit x approaches to 2 from right, f of x. X approaches to 2 from right means all x values are greater than 2. Okay, then which function to choose? Limit x approaches to 2 from right. Here x approaches to 2 from right means all x values are greater than 2. Na? When x values are greater than 2, which function to choose? This function, x square plus 1. Okay, x square plus 1. Now what to do? We need to calculate this part. How to calculate this part? In this function, wherever x is there, there you write 2. Okay, what you will get? 2 square plus 1. We got 5. Wow, you see here left hand limit is 5, right hand limit is also 5. What is the conclusion? When left hand limit is same as right hand limit, what is the conclusion? See here, I will conclude left hand limit equal to right hand limit. I got. From this what you can say? When left hand limit is same as right hand limit, then we say that therefore limit x approaches to 2 f of x. I got this value as 5. So what happened? Now I calculated this value. This value is 5. As I got this value is 5, now I need to calculate f of 2. I need to calculate f of 2. Okay. F of 2. I need to calculate f of 2. Okay. What is f of 2? To calculate f of 2, you just check what is the function. In place of x here 2 is there. Na? That means x equal to 2. You see in this equal symbol is there. You observe this one. In this equality symbol is there. When x equal to 2, which function to choose? We need to choose first function. So f of x is what? F of x is x cube minus 3. f of x is x cube minus 3. What is f of 2? F of 2 is 2 cube minus 3, right? F of 2 is 2 cube minus 3, that is 2 cube minus 3, that is 8 minus 3. 8 minus 3 is 5. So I calculated this, I got 5. I calculated this, I got 5. So what I can conclude? I will conclude here. Therefore, limit x approaches to f of x equal to f of 2. When I got this one, what I can say? I can say that f of x is continuous at x equal to 2. So I'll write the same thing. Therefore, f of x is continuous. Therefore, f of x is continuous at x equal to 2. I hope you understand this. F of x is continuous at x equal to 2. Right? What happened? Case 1 is over. I came to know that it is continuous in this zone. Now case 2, I checked the continuity at this point. At this point also I came to know that this is continuous function. Now I need to check continuity in this zone. Case 3. Okay. We'll do case 3. For that, I'll take this along with me. Oh, okay. Now I need f of x also now. I'll take this one. Case 1. Function is needed now to explain. Okay, I taken this also. I hope you understand that case 1, case 2. Now case 3. What is case 3? X equal to a. I am checking continuity at x equal to a, and I am checking continuity in this zone. Or in this zone, a value is what? In this zone, a value is greater than 2. In this zone, a value is greater than 2. When we say function is continuous at x equal to a, limit x approaches to a, f of x equal to f of a, then we say that function is continuous at x equal to a. So first I will calculate this, next I will calculate this. If both are equal, then we say function is continuous at x equal to a. Okay, so here limit x approaches to a, f of x. Okay, limit x approaches to a, f of x. What function to choose? X approaches to a, here a value is greater than 2. When a value is greater than 2, which function to choose? This x square plus 1. Okay, so I'll choose that function, x square plus 1. Okay, now I need to calculate this one. How to calculate this one? We do by direct method. In this function, wherever x is there you write a. What you will get? That equal to a square plus 1. So what happened? Now what happened? I calculated this one. I got its value as a square plus 1. Okay. Now I will calculate f of a. How to calculate f of a? To calculate f of a, you need to decide which function is we need to choose here. F of a. What you are trying to calculate? F of a. What is a value here? A value is greater than 2. When a value is greater than 2, which function to choose? X square plus 1. So in this case, f of x is x square plus 1. So what is f of a? In this, wherever x is there you write a square plus 1. So what is f of a? F of a is a square plus 1. So what happened here? I calculated this value, I got a square plus 1. I calculated this value, that is also a square plus 1. So what I can say? I can say that therefore limit x approaches to a, f of x equal to f of a. When I got this one, what I can say? F of x is continuous at x equal to a. So I'll write the same thing. Therefore f of x is continuous. F of x is continuous at x equal to a whenever a value is greater than 2. So what happened? I checked the continuity in this zone also. So here what I got? It is continuous. So in case 1, this is case 2. 1 minute. This is case 2. This is case 3. You check what happened in case 1. Case 1, you see here what happened in case 1. F of x is continuous. That means first case, tick. It is correct. For first case, it is correct. It is continuous everywhere. Okay. Second case, at x equal to 2 we checked. You see the second case, you look here. It is continuous. So second case also, yes, it is correct. Third case, just now we did third case. Now In third case, what you got? It is continuous. So third case, that means what happened? Case 1, case 2, case 3, everywhere it is continuous. So if it is continuous on its entire domain, that means this is continuous function. So I'll write the same thing. Okay, therefore from case 1, case 2 and case 3, what you can say? From case 1, case 2, case 3, we can say that f of x is continuous function. F of x is continuous. F of x is continuous function. When the function is continuous function, what they are asking in the question? Find all points of discontinuity. They are asking all points of discontinuity. So what you will say here? There is no point of discontinuity. There is no point. There is no point of discontinuity. So in this problem, there is no point of discontinuity. I hope you understand this solution, right? These are very lengthy problems. Now, one more problem is there. I'll just finish it quickly. I'm not going to explain much in this. First problem, second problem, third problem. This problem also follows the same procedure. You observe what is the domain of this function. This function is defined when x value is less than 1. This function is defined when x value is greater than 1. So, domain of this function is what? Domain of this function is all real numbers, right? So, I need to check for all points of discontinuity on real numbers, and here this function is varies at x equal to 1. When x is less than 1, this function. When x is greater than 1, then this function. Okay, so here at x equal to 1, this function. So here we do this problem in 3 cases. This is case 1, when a value is less than 1. Case 2, when a value is 1. Case 3, when a value is greater than 1. Okay, I hope you are all understanding, right? So case 1, what is case 1? In this zone, I am checking continuity in this zone. Okay, solution. Checking the continuity at x equal to a value is less than 1. Okay, when we say function is continuous at x equal to a, if limit extends to a, f of x equal to f of a. If this holds good, then we say that function is continuous at x equal to a. So first I'll calculate this one. Limit extends to a, f of x. Limit x approaches to a, f of x. Okay, that equal to limit x approaches to a. X approaches to a. Which function to choose? Here, what about a value? A value is less than 1. So we need to choose this first function. So what is that function? First function is x power 10 minus 1. Okay. Now I need to calculate this one. How to calculate this? In this function, wherever a is there, wherever x is there, there you write a value. Okay. That equal to. So here, in this, wherever x is there, there you write a value. So what you will get? You will get that a power 10 minus 1. Okay. So I calculated this one. I got it is a power 10 minus 1. Now I'll calculate f of a. Okay. I need to calculate f of a. To calculate f of a, you need what is the function here. Here, a you are trying to calculate. Now what is a value? A value is less than 1. So you need to choose the function, first function. F of x is x power 10 minus 1. So what is f of a? F of a is a power 10 minus 1. So here what is f of a? F of a is a power 10 minus 1. So I calculated this one, I got a power 10 minus 1. I calculated this one, I got a power 10 minus 1. From these two I can say that therefore limit x approaches to a, f of x equal to f of a. When I got this, what I can say? I can say that f of x is continuous. F of x is continuous at x equal to a. What about a value here? A value is less than 1. So I checked the continuity in this zone. What you got? You look here, what I got? I got continuous. So in this zone, there is no point of discontinuity. So case 1 is good. It is continuous everywhere. Now what is case 2? I need to check the continuity at 1. So that is case 2. Now what I need to check? I checked continuity in this zone. I got that it is continuous, and case 2 I am doing at x equal to 1. Okay, case 2. Oh, what is case 2? At x equal to a value is 1. I am checking continuity at this point. When we say function is continuous at x equal to 1, look here. When we say function is continuous at x equal to 1, yes, limit extends to 1, f of x equal to f of 1. Limit extends to 1, f of x equal to f of 1, then we say that function is continuous at x equal to 1. This is the case you may confuse, because calculating this part is not so easy. So what I'll do, I need to calculate this one. Okay, here why it is difficult, you will get a problem for this. Limit extends to 1, f of x. Here limit x approaches to 1, f of x. Here the problem is, as x approaches to 1, which function to choose? X approaches to 1 means all x values are slightly less than 1 or slightly greater than 1, but not 1. So x value less than 1 possible. In that case, we will choose this function. X value greater than 1 also possible. In that case, we will choose second function. So here what function to write? Both functions are eligible to write here. So directly we cannot calculate. Confusion is there. To avoid this confusion, just calculate left hand limit and right hand limit. Okay. So what I'll do here, to calculate this one, I need left hand limit as well as right hand limit. Okay. First I'll calculate left hand limit. Left hand limit at 1. So x approaches to 1 from left. This symbol indicates x approaches to 1 from left. F of x equal to limit x approaches to 1 from left. X approaches to 1 from left means what we learned? X approaches to 1 from left means all x values are less than 1. When x values are less than 1, which function to choose? We need to choose this function. So what I'll write here, the function is x power 10 minus 1. How to calculate limit of this? In limits chapter, for any problem, first we try by direct method. What is direct method? In this function, wherever x is there, there you write 1. So what you will get? 1 power 10 minus 1, that is same as 0. So left hand limit I calculated, I got left. What happened here? I calculated left hand limit, I got 0. Now can we decide this one? No, I need to calculate right hand limit also. What I'll do, I need to calculate right hand limit. Okay, limit x approaches to 1 from right, f of x. Okay, limit x approaches to 1 from right. X approaches to 1 from right means what? All x values are greater than 1. When x values are greater than 1, which function to choose? This function. Okay, so what is this function? This function is x square. Now I need to calculate limit of this. How to calculate limit of this? In limits chapter, for any problem, first we try by direct method. So wherever x is there, there you write 1. So what you will get? This is 1 square. 1 square equal to 1. Oh my god, left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. What you can say? Limit exists or limit does not exist. So here left hand limit is not equal to right hand limit. When left hand limit is not equal to right hand limit, then limit exists or doesn't exist? We know that limit does not exist. So I'll write therefore limit x approaches to 1, f of x does not exist. This does not exist. Actually what I am trying to do, I am calculating this value. And then I want to calculate this value. When I calculate this value, I got that it does not exist. When I calculate this value, I got that this does not exist. When this does not exist, how I can compare that these two are equal or not? This limit does not exist now. This limit does not exist. Then how I will compare? I cannot compare. Correct? Right? I cannot compare. So what I'll say? It is continuous. Can I check this one? Can I check this one? No, I cannot check because limit does not exist. So what happens here? I'll say that f of x is discontinuous at x equal to 1. This function is discontinuous at x equal to 1. You see here, in this case, I got discontinuity. I checked continuity at this point. I got it is discontinuous. They are asking find the points of discontinuity. That means I got a point here. At this point, this function is discontinuous. Now case 3. What is case 3? I need to check in this zone also. Okay, I need to check the continuity in this zone. This is case 2. This is case 1. This is case 3. Case 1, case 2 is over. Now case 3 I need to check. Okay. Okay, case 1, case 2 is over. Now I need to check case 3. Case 3 is easy only. What is case 3? What is case 3? Okay. At x equal to a value is greater than 1. When we say function is continuous at x equal to a, limit x approaches to a, f of x equal to f of a, then we say that function is continuous at x equal to a. First I will calculate this. Next I will calculate this. I will check both are equal or not. Okay. So limit x approaches to a, f of x, that equal to limit x approaches to a. What is f of x? Here a value is what? A value is greater than 1. When a value greater than 1, which function to choose? This function, x square. So what you will get here? This is a square. Right? Now I need to calculate f of a. I need to calculate f of a. Okay, what is f of a? What is a value here? A value is greater than 1. When greater than 1, we need to choose this function. What is f of a? F of a is a square. I am explaining little faster because all three problems are same type what we are doing today. Right? That equal. So what I got, therefore limit x approaches to a, f of x equal to f of a. Therefore what I can say? Therefore f of x is continuous. Therefore f of x is continuous at x equal to a, where a is greater than 1. Okay. So case 3, I got at case 3 what happened? It is continuous. So I checked the continuity on its entire domain. They are asking to find points of discontinuity. I got that at 1 there is a point of discontinuity. So what I will write? Therefore from case 1, case 2 and case 3, from case 1, case 2, case 3, what I can say? F of x is discontinuous at x equal to 1. Yes, at x equal to 1. At x equal to 1. Discontinuous at x equal to 1. I hope you understand.